So as we move forward with our correlation, notice how we were saying that R represents our sample correlation coefficient. But what we're kind of wondering how is with our sample, we notice that the sample, we pick up on that this represents a pretty significant value. But does this make it strong enough for our population? So what we do is we move into uh, using a table to test our population correlation coefficient, rho. So this rho is going to be our population correlation coefficient. So what we want to do is determine whether or not our sample allows us to say there's enough evidence to say our population correlation is strong. So as we move forward, we can use this little table here to kind of help us understand this rho. So again, we're going to use this table 11 from our correlation for our correlation coefficient rho. Let me pause a second and pull up our table. So this table will allow us to identify a critical value that we can compare R against. So in using the table, one of the things we have to identify is the number of ordered pairs of the data sample. So the other thing is, so N is going to be the number of ordered pairs in the data sample. Then alpha is going to be the level of significance. So we're going to be using these two things to identify the critical value in the table. And then from there, once we've identified the critical value in the table, we're going to compare the absolute value of the sample correlation coefficient. So we're going to identify the absolute value of R. If it's greater than the critical value from the table, then the correlation is coefficient. So that's kind of what we're doing. If it's not, then there's not enough evidence to conclude that the correlation is going to be, the population correlation is going to be significant enough. And then from there, this is going to lead us into doing hypothesis testing. So our example with Old Faithful, notice how we came up with this R value of 0.979. And like I said, it's pretty close to 1. So we really feel like this is a strong correlation coefficient. But with this level of stiffness of 5%, so again, with hypothesis testing, remember, we're testing the null hypothesis. And with the null hypothesis, what this is saying is there's a 5% chance that we're testing the null hypothesis, and we kind of end up testing that we're assuming it's true, but we reject it anyway. That's kind of what this is saying. There's a 5% chance of that happening, which is a good thing. So we don't want that to happen. So basically what we want to do now is, since there's 25 ordered pairs, if we look at our table, 25, and since our level of stiffness is 0.05, this gives us this critical value, which is just 0.396. So now since we have a bunch of data, notice how that R value starts to decrease as well. So the more data, you kind of see this critical value kind of decreases. So the absolute value of R, so the absolute value, let's see if this thing to work here. I'm going to jump from table to table, it kind of messes with it. So if the absolute value of R is greater than the critical value from the table, then we're going to say the correlation is significant. So we have the absolute value of 0.979. And if we look at the table, the critical value in the table, since we have a 25 with a 5% significance, we're seeing this 0.396. Remember, the absolute value of a positive is still a positive. Is that greater than 0.396? So yeah, this is true. So what we can pick up on then is the correlation coefficient from our sample is allowing us to say that the population correlation is also, so the population coefficient, correlation coefficient, I should say, is going to be significant. So what that kind of means to us is the data is going to be able to be a good predictor of whatever we're doing. So if we create some type of math, this math is going to be a good predictor into future happenings based on the data itself. So I don't know how to really make a row, so I'm going to kind of make a P. So you have to understand this P. I may make it just a little bit heavier and call that row. So we can use this table and test the R value against the critical value in the table, and that'll tell me whether or not I can kind of draw conclusions about my population coefficient, correlation coefficient. And since R was greater than this 0.396, we can kind of now say that with respect to the population, that there is significant evidence to move forward with our data.